Okay, in this video, I'm just going to redo the same problems I did, but I'm going to use a shortcut. Okay, if you have not done the other two videos, if you haven't done it the long way, please, I beg of you, go back and do it the long way. If you don't do it the long way, you won't understand how to solve harder problems. Because I'm going to use, in effect, shortcuts, and you won't understand why they work. And so here's the shortcut. If I have two numbers and I'm taking a number A and I'm adding a negative B to it, then I can rewrite this as simply A minus B. So when I did them before, in this first example, I was going to do, I'm going to add a 3 to it. That's fine. Add a 3 to both sides and I get 10. That's good. Okay, now, I'm going to go through this again, but in x, I have x plus, I'm sorry, in the second one I have x plus 5 equals 4. Now, I have to add a negative 5 to that to make x plus 0. Because when I have x plus 0 is just x. So rather than add a negative, I can actually subtract. They mean the same thing. So I can use that knowledge to, in effect, make a shortcut. Now, not only am I going to make a shortcut, but I'm going to perform these in a slightly different way. If you look at the addition principle, it says you have to do it this way. There are other ways to do it that basically get the same thing, and they're a little bit neater. And by neater, I mean we tend to work in columns easier than rows. And so I run a column method, which is very common when we first start teaching people how to do algebra. It's not technically correct, and mathematicians don't typically use a column format. They will typically run in a daisy chain, really. And so, or use words in their arguments, or symbolism. But for right now, we're going to go ahead, we're going to add 3 to both sides. And I'm going to signify that by adding 3 to the columns. When I do that, my goal is x plus 0. It's always my goal. I have to have my goal in mind, otherwise I don't know what to do. And so when I do this, I'm going to get x, and then negative 3 plus 3 is 0, equals 10. Well, anything plus 0 is that anything. That's the additive identity. And so we get x equals 10. Now I can take that 10 and stick it in for x and check. 10 minus 3 is 7. Is that true? Yes, it's true, and so 10 works, and so there's my answer. Okay, and all it is a slight change from how the addition principle looks and how subtraction looks. Okay, so let's do these next two. Remember, my goal in this first part is to get x plus 0. That's a goal. To accomplish that goal, I need to get rid of this 5. I need to add its inverse. But instead of adding its inverse, I'm going to subtract 5 from both sides. And so now I have 5 minus 5 is 0. Bring down my x. And now I have over here on the other side of the equal sign 4 minus 5. Well, that gives me negative 1. And so now this x plus 0 becomes x because it's the additive identity, and I get x is negative 1. What I can do now is I can take that value of negative 1, stick it in for x, and say negative 1 plus 5 is in fact 4, and so that equals 4. True. So both of these are good. And you'll notice it moves along ever so slightly quicker. This is the second time I'm doing these problems, and so you already know what the answer is. That's part of the reason I'm moving through it quicker. On this third one, again, we want x plus 0. That's our goal. Until you get very good at it and can think of your goal in your mind, write it down. It doesn't take that long. And so in order to get rid of this negative 6, I have to add 6 to it, and the effect is negative 6 plus 6 is 0. Bring down my x. Negative 10 plus 6 is negative 4. And so x plus 0 is x. 0 is the additive identity. 0 plus anything is that anything. So I get x equals negative 4. And I can take that value and stick it in for x and say, oh, well, negative 4 minus 6 is negative 10. All right, now, to finish this out, another common mistake that I've seen students make in the past is that they always think that x is the same. Well, I already solved for x. Every problem is unique. We don't have to call it x. We can call it anything we want. In fact, sometimes we do. It's just that x is a very common variable for us. X, y's, and z's are very, very common. And so that's why we use them. Out in the real world, no, they use letters that make sense. Math doesn't have to make sense. We don't have that restriction. So as you're working through this, just know that each problem you come to is its own separate problem. You don't have to get the same answer for them all.